Alright, so for this podcast, we're going to be looking at parent functions and transformations. Um, just keep this in mind in math. Transformations are just a fancy way of saying changing. So we're going to basically be changing the graphs. Um, parent functions. The parent function is the equation that the new ones come from. Just like you come from your parents, these equations come from where you start with the parent. Okay? So for the linear parent graph, so the graph that all other graphs come from technically is from the equation just y equals x. Okay? All linear equations can be seen as transformations of this function. Okay? Let's take a second and talk about this y equals x graph because this tricks people up a lot. Okay, so remember, we are looking at it in terms of, let me start that over. Remember, the very important formula we talked about was slope-intercept, y equals mx plus b. So if we look at this parent graph, or this parent equation here, well, what is our slope? What is our number in front of the x? There is no number. Remember, when it's not there, it's there but it's invisible. X means 1x, so the slope here would be 1. The y-intercept is after the x. It's added or subtracted, right? Well, there's nothing here. In this case, nothing there would be 0. It's like saying adding 0. Okay? So that's how you would graph this parent graph. You would start at your intercept as 0 and have the slope as a positive 1. Okay? So let's look here at this first example. Okay, we're going to graph the following equations. Now, here's what we're basically doing. We said transformations are changing. Well, we're going to be changing one of two things, either the slope or the intercept. Okay, and changing the slope does something different than changing the intercept. And that's what we're going to be looking at here, basically. Okay, so for this first equation, here's the parent, right? This is the parent graph, y equals x. So we just said y equals x. That means the y-intercept is 0. And the slope is 1x. So that means we go up 1 over 1 every time. Alright, so this makes basically like a perfect diagonal. Okay? So that is our parent graph. Alright, so now as you can see, look at the next graph. It's almost the same. Now it's y equals x plus 1. So if I graph that one, now what's my y-intercept? A positive 1. Now what's my slope? It's still 1x. So now I'm going to take my positive 1 slope, up 1 over 1, and I'll graph this with a dotted line here. So we can see a little bit of a difference. So see, that's that graph. And then if I do the next one, which is the y equals x plus 2. Now my y-intercept is at 2. Slope is still 1 for 1x. Now let's look at that one. That one's off a little bit, but you kind of get the idea. So here's the thing. Are we changing the slope or the intercept? Look, all these lines have the same slope. They're in the same direction. What we're doing is we're changing the y-intercept. So here's the key. When a number is added, we added, because remember, this meant plus 0. That's why it crossed at 0. We did plus 1, plus 2. So when the number was added, look at how the graph moved. It shifted up. Plus 1 meant we moved it up 1 space. Plus 2 meant from here to here, it went up 2 spaces. That's all it's doing. By changing the intercept, you're just changing where it crosses the y. We're not changing the slope there. Okay? Alright, let's look at this one. Once again, we'll start with the parent graph. Y equals x. Slope is 1. Y-intercept is 0, right? So let's graph that one here. Still slope of 1, up 1 over 1, up 1 over 1. Alright, so let's graph this one here. Alright, so there's the parent graph. Now let's transform it or change it. Now here's the first one here. Now it's y equals x minus 1. So the y-intercept is negative 1, the slope is still 1. So now I'm going to start my graph at negative 1. That's the intercept, but the slope is 1. Up 1 over 1, up 1 over 1. Now let's graph this one. So that's the new line there. Okay, and then let's look at one more. Now it's y equals x minus 2. Y-intercept is negative 2, slope is still 1. So negative 2 for the intercept, slope is still 1, up 1 over 1. Now let's graph this one. Now as you can see here, same slope, we never changed the slope. The slope was always 1, 1, 1. What did change was the y-intercept, but now instead of adding the y-intercept, we're subtracting it. So here's where we started, look what happened to the graph. It shifted down. And that makes sense mathematically, right? When you add it, positive, it goes up. Subtract, negative, goes down. Alright, so that is, one type of transformation where you're changing the y-intercept. So changing the y-intercept just shifts it up or down. Okay? Now let's look at a different change. Okay? Always starting with the parent graph, though. So by now we know that that's the intercept of 0. Slope is 1. Alright, so there's the parent graph. Now look at the new graph. Now we have this y equals 2x. Now look what we changed. Well, what's the y-intercept? It used to be plus 0. It's still plus 0. There's no y-intercept. What changed now is the slope. From 1, now the slope is 2. So now look, I'm going to start on the same y-intercept. But now my slope is 2, which means 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Okay, so now when I graph this one, it's going to look like this. Okay, and let's change it yet again here. Okay, now the equation is y equals 4x, which is still plus 0, still no y-intercept. So I still start here in the origin, the middle, but now my slope is 4, which is 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Alright, so now let's take a look here. This graph goes something like that. Alright, so now the graph does something totally different. You see the graph did not slide up. Now the graph is like becoming more steep, but is still crossing at 0. Okay? So what's happening here is that when the x is multiplied, basically there you're changing the slope. The line gets, we started here, see how it's getting more up? It's getting steeper. The line gets steeper the higher the number. Think about it. Parent slope, this is a slope of 1, right? And then we multiplied it by 2. So this got more steep than this, right? But then we did times 4. It's even more steep. So the higher the slope, the steeper it gets. Okay? Alright, next page. Let's see another type of transformation. Alright, once again, always starting with that parent graph. I know I've been seeing it a lot here. Starting at 0, slope of 1. Okay? Okay, so here's our parent graph. Now, look at what we're changing. Once again, now we have y equals 1/2 x. Plus 0, still the intercept is plus 0. We're not changing the intercept. Once again, we're changing the slope. So the slope is from 1, now it's 1/2. It's already a fraction, so I just go up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. Alright, so now if I connect this one, the slope is going to be like that. Okay? So y-intercept has changed, but now we're changing the slope. Alright, and let's look at one more. Now it's y equals 1/5 x. Still plus 0. Still the origin is the intercept, 0. But now it's up 1 over 5. Up 1, 1, 2, 3, 4, 5. Up 1, 1, 2, 3, 4, 5. Okay, so now when I graph this one, it's going to go like that. Alright, so now here's the thing. This one says when x is multiplied by a fraction. Remember the last one, it was multiplied by whole numbers. Now it's multiplied by a fraction. Remember, fractions mean dividing, really. So think about what that's going to do. When you're technically dividing the slope, the line does not get steeper. Look, it started here, it went here, it went here. It's getting flatter. the line gets flatter the lower the fraction. So think about it. Here was the parent, slope is 1. And then we cut the slope in half, 1/2. So it's flatter. And then we cut it to 1/5. It's even more flat. It's getting closer to 0. It's getting closer to being flat. Okay? Alright, last type of transformation. Okay? Once again, here's the parent graph. Y equals x. That is the intercept of 0, slope of 1. Alright, so there's our parent graph. Now look at this one. Look at how we're changing this one. Now it's y equals negative x. Well, negative x, what's that mean? The intercept is still 0, but now the slope is negative 1. So if I throw that over 1, so I'm going to start it at the origin. But negative 1 over 1 means I go down 1, right 1. So now my slope, whoops, is going to go like that. Okay. So now the graph goes like that. See what happened there? Alright. So look, it's the same slope. It's like a mirror image, but it's going the opposite way. Right? Let's try one more of these. Look at y equals 2x. So y equals 2x, the intercept is 0, but now my slope is 2. 2 over 1. Up 2 over 1. Up 2 over 1. So let's take a look at this one. Alright, there's the parent graph here. Now let's try to graph if we change it to y equals negative 2x. Alright, so when I graph that one, intercept is still 0, but now my slope is negative 2. Throw it over 1, so I have my rise and my run. I'm going to rise down 2 over 1. So start here, down 2 over 1, down 2 over 1, down 2 over 1. So if I graph that, it's like the opposite of that one. Okay? So, to sum this one up, now when you multiply by a negative number, the line, we say it reflects, goes the other direction. Okay? It's like the same line, just opposite way. Just like positive and negatives are opposite of each other. Okay?